Day 10 of 60. Today we are talking about structured logging, and I want to start with a real scenario. Last month I spent 2 hours tracing a payment failure across 4 microservices. The root cause was a downstream timeout, buried in 600 gigabytes of unstructured text logs. 2 hours. If we had structured logging, that investigation would have taken 5 minutes. Structured logging is not a nice to have. It is foundational infrastructure for any production system. Let me explain what structured logging actually means. Traditional logs look like this: a timestamp, a level, and a message string. Every service formats them differently. Timestamps vary. Field order changes. If you want to extract a user ID or an order number, you are writing regex and hoping nobody changes the format. Structured logging means every log event is a JSON object with consistent, well-defined fields. Timestamp, log level, message, service name, and any context fields you need. Your log aggregator, whether that is Elasticsearch, Loki, or Datadog, indexes those fields automatically. Instead of grep, you write a query: service equals payment and level equals error and order ID equals 9821. You get results in seconds. Now let me show you real code. In Python, struct_log is the library I reach for. You configure it once with processors for timestamps, log levels, and JSON rendering. Then every log call takes keyword arguments. Log.info, order.processing started, order ID equals 9821, user ID equals 441. The output is a JSON line with every field indexed. In Go, you use Zap from Uber. Same concept. You create a production config with JSON encoding, set your field names to match ECS or your team standard, and use typed fields. Zap.string for request ID, zap.int for status code, zap.duration for latency. In Node, Pinot is the fastest structured logger. You create an instance with a service name, and every log call accepts an object of context fields. All 3 libraries follow the same principle: key-value pairs, not string concatenation. Correlation IDs are what make structured logging powerful across services. Here is how it works. A request hits your API gateway or edge proxy. You generate a unique ID, a UUID, and attach it as a header, xRequestID. Every downstream service reads that header, binds it to its logger context, and passes it along to the next service. Now when you search for that request ID in your log aggregator, you see every event from every service that touched that request. The full life cycle. Without correlation IDs, you are jumping between services trying to match timestamps. With them, one query shows you everything. In Python, I use context variables and middleware to bind the request ID automatically. Every log line in that request scope includes it without the developer doing anything extra. Log levels. Most teams get these wrong. Here is the breakdown that actually works in production. Debug is for development only. Never enable in production unless you are actively investigating an issue. Info is for normal operations. Request handled, job completed, cache refreshed. These confirm the system is doing what it should. Warn means something unexpected happened but the system recovered. A retry succeeded on the second attempt, a deprecated API was called. Error means an operation failed and needs human attention. Payment declined, database timeout, upstream 500. Fatal means the process cannot continue. If your on-call engineer gets paged, the error logs should tell them what happened, which service, which request, which downstream dependency, without reading source code. 2 more critical topics. First, what not to log. Never log PI. No emails, no passwords, no credit card numbers, no session tokens. If you need to reference a user, log a user ID. Never log full request or response bodies in production. Log a hash or a truncated summary. Second, log sampling. At 50,000 requests per second, logging every info event costs real money in storage and indexing. The strategy: log 100% of errors and warnings. 100% of requests that breach your latency SLO, and 10% of successful requests. You can implement this at the application level or at the collector level with OpenTelemetry. Finally, pick a log format standard. Elastic Common Schema uses at timestamp, log.level, service.name. OpenTelemetry uses timestamp, severity text, body, resource. Pick one and enforce it across every service with linting. The worst outcome is every team inventing their own field names, because your dashboards break on every deploy. Structured logging is infrastructure. Get it right on day 1. Day 10 complete. See you on day 11.